Now we're going to make a contour map, and we have our function z equals x squared plus 4y squared. We know that this is a paraboloid opening up from the origin from what we've learned in section 13.6, but let's check out the contours for it. So when we say we want to make contours with c equal 1, 2, and 3, that means we're putting those values in for z. So we have z equals 1, so 1 is x squared plus 4y squared, and this is an ellipse, right? So that vertical slice, that trace, is an ellipse, and so we'll draw an ellipse. And what ellipse do we have? If if y equals 0, x equals plus or minus 1. So let's start with that, plus or minus 1 on the x-axis. If x is 0, let's see, y squared is 1/4, so y is plus or minus 1/2. So that's the ellipse that we get. And that ellipse is the contour that corresponds to the height of the function z equals 1. That's all of the points that exist at that height, z equals 1. If you walk around the paraboloid is a bowl opening upwards, and the z equal 1 plane is this plane that slices through it, and that slice is the ellipse that we just talked about. So if you walk around this bowl, this paraboloid, at that height, you stay at that height. Those are all the points at that elevation. So we've drawn our first contour. Our second contour, we're supposed to let z equal 2. So we'd have 2 equals x squared plus 4y squared. Now this is again an ellipse. So that's great. It looks like all of our contours are going to be ellipses, and that makes sense. Anywhere that we slice this paraboloid, we're going to get an ellipse out. So, and that's what these contours are, these intersections of the horizontal planes with the surface itself. But what ellipse do we get? If y equals 0, then x is plus or minus the square root of 2. That's a little bit bigger than 1, so we get an ellipse that's just slightly bigger, and so we can draw that. Now I could write down decimals and get exact spots on this on these curves, but I don't want to have to do that. So there's the z equal 1 contour. There's the z equal 2 contour. So we see that this is going uphill, right? That this is increasing in elevation as we go away from the origin. And the same will be true for the third contour we've been asked to draw. If I let y equal 0, I get x is plus or minus the square root of 3, which is bigger than plus or minus the square root of 2. And so that third contour is also going to be an ellipse. And as you can see, you don't have to be an artist to make a drawing. These are pretty shaky ellipses, not my best work, but it's okay. It conveys the point, and this is our contour map. And I've labeled the contours with the appropriate elevations on the map. So you can see that if you walk around this contour here, you're at elevation 1. If we walk around the middle contour, here, we're at elevation 2, and so on. That's how we can read our contour map. So we'll have problems where we're asked to sketch a contour map, and this is how we do it. We put in these values for z and sketch whatever the resulting thing is.